nós vamos recomeçar os trabalhos, certo? Para o pessoal que está chegando agora, professora, pode mostrar o mascote? Please show the tiger.
Oh.
Para os estudantes que chegaram agora, nós vamos depois sortear 3 desses lindos tigrinhos. É o tigrão do Ursinho Pooh, né, que é o mascote oficial do Projeto Alice, né? Vocês que acabaram de ingressar aqui no auditório terão direito a concorrer a 3 tigrinhos desse aí até o no finalzinho da palestra, ok? Não sei se agradou vocês, mas a turma que tem assistido, teve um aí que eu fiquei até com medo de rasgar, porque caiu na mão de 2, aí um puxava de um lado, outro puxava do outro. Aí. Bom, nessa etapa, agora nós vamos começar, é o momento em que a professora Wanda vai falar do Alice 3.0, tá certo? É um Alice melhorado em relação ao 2.2. Para os alunos que chegaram agora e têm dificuldade de tradução, de entender inglês, nós temos tradução simultânea. Vocês podem, deixando um documento, pegar um kitzinho para ouvir a explicação. O inglês da professora é muito bom. Quem sabe falar inglês, eu recomendo que pratique o inglês aí. Professora Wanda, por favor, faça as honras.
Obrigado. Bom dia. That's the extent of my Portuguese. I am very pleased to be here today. I want to express once again my thank you to Professor Edson for his generous hard work and many hours devoted to making arrangements for me to travel here today, to be with you and to share with you. If you were not here yesterday, please allow me to explain about Tigger. Did you explain? No. Okay. So I will explain about Tigger. Tigger is the mascot of the Alice Project at Carnegie Mellon University. Alice was originated by Professor Randy Pausch, who began Alice in the early 1990s. I met him in the late 1990s and joined the Alice team. In 2007, Randy was diagnosed with pancreatic cancer. And pancreatic cancer is about 97% fatal, almost immediately. So he called me, had me fly from Ithaca, which is where I was teaching, to Pittsburgh. And when he told me, I cried. And then he told me I couldn't cry anymore, that we could be Eeyore, as in Winnie the Pooh, and we could feel sorry for him and be very sad and downtrodden and give up. Or we could be Tigger. And the thing Tiggers do best is bounce back. And so he made the decision to be a Tigger. And so this is the mascot. His name is Tigger, spelled T-I-G-R-R-R-R. And he's bouncy. He is our mascot because we have a very positive point of view toward the future. We greatly honor and remember Randy Pausch as the originator. However, we have taken on the task of carrying the project forward, and Tigger is our way of saying, Randy, we will make it work. So yesterday I gave a short presentation and on Alice 2. I began my presentation with a short history of the Alice Project in the morning, and then in the afternoon talked about Alice 2 and the problem-solving approach that we use. Today I am going to once again talk about the problem-solving approach, but before, and I'm going to talk about Alice 3. But before I do, I want to give you some sense of our vision and our perspective from the Alice Project point of view. I am a member of the LACS, L-A-C-S group in the United States. LACS is Liberal Arts Computer Science Computing Consortium. And this is a group that works with curriculum for across the disciplines for, in which computing plays a major role. I also, my department chair at Carnegie Mellon University, has been part of the process of working to put computational thinking into our curriculum, K through university level. And so I want to give you some sense of this vision. I will not spend a lot of time on it because that would take us the rest of the day. All right? But our objective is to start young. This is because we realize that if you want a championship football player, being in the States we call it soccer, here I know it's known as football, you start with children when they are young, and you provide instruction and activities for them in kindergarten, in primary school, in secondary school, and into college. And over many years, they gain the skills and the capability of playing for their own enjoyment, as well as for the possibility of perhaps becoming a professional player. We believe that we need to do the same in the academic arena. We do this with reading and writing and arithmetic and science and social studies. These are standard parts of our curricula, beginning in kindergarten and working all the way through 12th grade and into the college and university level. That curricula was put together over hundreds of years prior to something called computing technology. We now live in an era where we have cell phones, we have television sets, we have computers, we have iPads, we have Kindles, we have internet. What we don't have is computing in our curriculum. Doesn't make sense to me. So we believe we need to start young, and we need to build skill and interest over many years. It's one thing to have a summer camp for our children as 6th graders or 8th graders or 10th graders and have them work with computers for a short period of time. That becomes entertainment because it's too short. It's not enough time to really build the skills and the interest. We need to work over many years and reinforce and introduce new concepts along the way and prepare our students for the future. And for those of you who are today's students, I'm counting on you. Please hear what I have to say today, because making this happen is up to you. We will try to get it started, but you must pick up the torch and carry it forward. Along the way, we need to inform our students about career opportunities. Yesterday, I made a presentation regarding future occupations and job openings in the States. We anticipate over 200,000 jobs that will not be filled between now and the end of 2012 because we are not graduating enough informatics majors, computer science, computer information studies, information technology. Why aren't we graduating enough? Because we did not properly prepare our students. We did not build skills and interest over time. So just to give you some sense of our vision as the ALICE Project sees it, please allow me to say that this is not something that I consider to be written in stone. These are ideas. These are visions. These are things to think about. These are things to make decisions about, not something that is rules, not solidified. Just let's put these cards on the table and let's talk about it. Let's play the game together. Let's work to help put into our curriculum the concepts, the interests, the skills that our children need in the 21st century. So I look at this as being 13 to 17 years that we need curriculum to be put into position. This starts at kindergarten, goes all the way through at least the first year of university. I have divided this up into segments, and this is arbitrary in some ways. It is also based on the curriculum, the school divisions that we have in the States. We have as our primary school, our elementary school, kindergarten through 5th grade, approximately. Depends on the state. Then we have what we call middle school, which is between the primary school and the secondary school. And that typically is 6th, 7th, 8th grade. Then we have high school, which is typically grades 9 through 12. But I put this as 9 through 11 because generally 12th graders should have completed all of the fundamental curriculum and be preparing for college. And many of our 12th graders take what is called an advanced placement course, for which they get college credit. So they may take this course as a senior in high school and then take those credits with them. They earn those credits. They win those credits to take with them to college, which makes things a little easier at the college and university level. So 17, well, at least 13, maybe as long as 17 years. We have a lot of time now. What we need is to think about tools. How can we support our students and our teachers? In the previous presentation, someone said something about a debate between Alice and Scratch. I must say to you, we do not view that to be that way. We believe that there is room for many tools over 13 to 17 years. So we do not have enough tools. We need more tools. I think that Alice paved the way. Along came Scratch. We already had Logo. We had Carl the Robot. Some of you may have heard of that one. There's something called Giroux. There are many tools that we have now. More need to be developed. We need to evaluate these tools and to decide where will they be used to greatest advantage. Which ones are simple enough to use at the primary school level, K through 5? I believe Scratch belongs there, without a doubt. So I was thrilled, Professor George, to see your presentation today. I was like, yes, go get them. All right? I will stand up and applaud your efforts. I think Logo, something, a simple editor like Notepad, introducing them to using the internet. I would like to add that along with the use comes responsibility. And we need to think about safe online surfing. That's called SOS. Help. Safe online surfing. All right? Paint, internet browsers, and so forth. That list is probably much longer than what I had room for on my PowerPoint slide. But I would hope you get the idea that you start there and then you build. All right? Alice 2.2, we have had people in 5th grade, 4th grade, working with the more talented students. We have had teachers at the primary level who take the tool and prepare instructional materials for their students to use. The students aren't creating them there. The teachers are using the tool to create materials that they can use for teaching reading and writing and so forth. At some point, we need to make a transition from being the consumer to being the user. And so the user meaning the producer, the person who writes the code with that programming language. So we may start at the primary school with being a consumer, how to use the existing tools. We need to, at that level, we need to start moving them into how can I be more creative? And that includes learning some fundamental programming concepts. All right? And then in grades 6 to 8, things like Alice 2.2. Alice 2.2 can be used at different levels. You can choose how you teach it. You can choose what features you use, and so you can select to have them write all of their program code in one big procedure. And those of you who are university professors, please stop cringing. Okay? At that level, if they can put together 10 lines of code all in a row, you applaud. All right? Writing methods and functions and using parallelism and so forth can come later. Let's start with the simple steps and move up from there. This is also a time when you would want to introduce something like GIMP. You might want to have them build web pages with HTML. I'm not sure exactly where this goes. I am not a primary school teacher. I am not a middle school teacher. And so I'm not the expert in that area. All right? But I'm willing to work with these teachers to prepare curriculum that's appropriate for your students. That's the bottom line, right? Is get out there and offer a helping hand. But let the teachers in the classroom make the decision about what's appropriate for their students. They are the experts at their level. All right? Then in grades 9 and 10, Alice 2.2 still could be used, but at a higher plane. Having them write their own methods, having them write their own functions, having them use interactivity, having them use concurrency, building on what they learned in the previous grades. There are other tools that could be used. 3D modeling is of great interest to students at this level. They would like to use something like Blender for building 3D models. We are working on how to help students learn to build something in Blender and transfer it into Alice. We don't have that yet. We're working on that. We recognize that need. Then we are ready for real world kind of stuff, yes? We are looking at the university level at programming languages such as C++ and Java and Python and Delphi and others. Yes? Alice 3 is being built for that age level where we want to focus on this transition from what we have learned over time into that professional production level language. This is where you would teach something like MicroStation, right? Where you move into the professional level tools. And hopefully, if we have built this all the way through, we will have many students who feel confident, who actually have the skills to say, I want to be a computer science major. I want to be a computer information systems major. I want to be an IT person. Why? Well, because that's where the good paying jobs are. That's where the jobs are going unfilled. Makes sense to me. It's nice to take home a good paycheck. It's also nice to do something you enjoy doing. And we want to put the two together. All right. What this really means is that we have to decide what are the concepts at each level that we want to achieve. And this is conceptual. And so what we have to do is to match the concepts with the tools. So I think probably at the primary school level, we want to talk about coming up with a sequence, an order in which steps are accomplished. Coming up with simple control statements such as an if-else. All right? Because if some condition is true, you want this to happen. Otherwise, you want something different to happen. Relational operations, the less than, the greater than, the equal to. These are things that we can accomplish at the primary school level. And in the middle school level, we're going to go after problem solving. This is usually where word problems are introduced at this level. And in computer science and CIS and IT, every exercise students are assigned, every programming exercise they are assigned is a word problem. All right? And so one of the things that I talked about yesterday was this thing called problem solving, which is nothing more than a slight variation on the traditional problem solving steps that we've been teaching in math for years and years and years for word problems. And I went through this. If you were not here yesterday and you would like to know more about the problem solving, this is the design. And those of you who are from the School of Engineering know design is so, so, so important. Yes? And so this is what we're working on there. All right? So problem solving, learning how to abstract. Students do not automatically know how to abstract. So that's something we have to work on. Learning about an object and actions. Methods are actions performed by objects. Functions are questions we ask about objects. Data, the information, like how far is it from the penguin to the basketball or the soccer ball or whatever. Variables, logic, storyboard design, online safety. I think that online safety probably belongs at absolutely every level. And then in high school, the problem solving, communication and ethics, 2D versus 3D, building 3D models, and that list probably needs to have everything in it that the 6 through 8 has, but just to a greater depth kind of thing. And then at the university level is where we start working on classes and objects and procedural and functional methods and scope and encapsulation and inheritance and polymorphism. And does that make sense to you? Yes? Good. That makes me feel better. I'm not some crazy woman. Well, maybe a little. I think it's a little insane to take on the world, all right? But basically, what we're trying to do is spread the word, all right? I have to say I've been in many countries and talked with leaders in many countries, and I think that of all the places I've been, this has been one of the most receptive groups of people that I have communicated with. I see smiles on your faces. I see heads nodding, and I'm like, yes. Okay? So that's great. So with all of this in mind, what I want to say to you is that Alice exists in 2 forms. It exists as Alice 2 and as Alice 3. And right now, Alice 3 and Alice 2 have very different target populations. That is, we intend Alice 2 to be used with younger students, where we're not worried so much about classes and scope, all right? What we're worried about are those fundamental programming concepts. And then Alice 3 is for the older students. And this is where we're building on what we learned with Alice 2, and we are making a transition from there into a professional production level language. Right now, the language we're working on is translation into Java, but we certainly have on our list other languages we could transition to. But Java, we had to pick one, and Java is the #1 programming language taught at the college and university level in the States. So that's our obvious choice as the first one. All right? Okay. So with all of that said, and thank you for your patience with me, I am going to go back to this problem that we started yesterday in Alice 2, revisit this problem, and then we're going to do the same thing in Alice 3, and then we're going to take it into Java. In my dreams. I planned for a slightly longer presentation, so I'll do this as quickly as I can. In this problem that I presented yesterday, we have a penguin that's discovered a crate that contains a ball, all right? And the penguin wants to play with the ball, whether it's a basketball or a soccer ball, whatever, okay, a ball. Now, the penguin doesn't really have arms to pick up the ball and do things with it, so it has to do what we do in the soccer football, where you have to use your body to bump into that ball and propel it in the direction you want it to go. And so we are going to create this little game where the penguin tries to get the ball to roll into the hole in the ice where you can see the water. And if he is successful in getting the ball into the water, then we get 2 points, all right? And we're going to give him 5 tries. And this is a typical kind of little game that you might expect kids to play, and penguin is no different. Okay, it just happens to have fur and webbed feet. All right. So what we did yesterday was we went into the first problem-solving step, which basically is to read and understand the problem, figure out what the objects are, what the actions are, and of course this is a beginning of abstraction. Taking the details out and deciding what's important that you need for writing your program. And then we set up the scene. And I went through this yesterday in Alice 2, where you create these objects. In Alice 2, what we have is a gallery of classes. These are Java classes. Each class defines a kind or a type of object, and we instantiate those objects in the world. Now, if I'm talking to 6th grade students, I don't tell them that these are classes in Java. I tell them this is a 3D model. Close enough? All right? It's a Java class that defines a 3D model, but they don't need to know all that, right? And I don't talk about construction. I just say, let's create one of these. So it's the vocabulary that you use and the concepts that you're introducing that makes a real difference. But it lays the groundwork for later, more in-depth understanding. You did that in math. Don't tell me you didn't. You started out learning to count. Then you learned how to add. Then you learned how to subtract. And the next year in school, they said, remember how you added things together? Well, we have a way of adding lots of things together all at once, and we call it multiplication. Yes? Well, you see, folks, what we want to do is in the lower grade levels, we want to create objects out of 3D models. In the upper grade levels, we want to extend a class and instantiate an object of that class by calling a constructor. Yes? Yeah. Okay. I think you got the idea, right? Okay, now what we did yesterday, because you're all adults, was I said, well, we wanted the penguin to swagger, and then we want the penguin to move forward. If I were teaching 6th or 7th graders, I would have just created my statements all in the main method, which in Alice is called the first method. All right, my first method. I would have just written all my program code right there. But because you're adults and you understand about classes and methods and such, I created a method with you named Swagger. And here's where I wrote my code. And then in the main method, I called the Swagger method. So I adjusted what I'm teaching to the age level, to my audience, for my objectives as a teacher. All right? So when we click on play, the penguin swaggers. I'd say he's rather confident, all right, that he's going to hit that ball. Now, what I want to do is to have him move forward and bump into the ball and then have the ball move on, all right? Now, I can do this in Alice, too, by saying if, let me put it this way. When I wrote Swagger with you yesterday, I wrote it for the penguin because it's just the penguin doing the action. But now I want the penguin to move forward, bump into the ball, and have the ball move forward. And so now I have two objects involved. And so because I have more than one object involved, I write that method as a world level method. All right? Because it doesn't belong just to the penguin. It doesn't belong just to the ball. It involves two objects, and so this belongs to the world. So I go to the world and I say I want to create this new method to push the ball. And in here, I select the penguin, and I tell the penguin to move forward. Well, Alice wants to know how far, okay? What amount? I don't really know how far the ball is in front of the penguin. And so I'm just going to put in 1 meter, all right? And then I would like to have the ball, assuming the penguin bumps into the ball in 1 meter, I would like to have the ball move forward and once again, I don't know how far. So I have selected 1 meter in each case. I call these placeholders. I don't really know how far, okay? But I have to put something in the drag and drop environment. Same thing is true in a production level programming language. When you call a method that has parameters, you've got to send something in. It just won't work until you tell it something. And when you don't know what it is, then you put something in just to try it. All right? And so, let me play this and just see what happens. All right, you were here yesterday, most of you, or many of you. Why didn't that happen? Well, I wrote a method called push ball, but did I tell Alice to execute that method? No. Writing a method just doesn't do it. All right? You've got to call it. Yes? Okay? Wanting to order pizza does not deliver a pizza to your door. You have to call the pizza shop. And you have to tell them what you want. Yes? The size of the pizza, what you want on it, where to deliver it. Yes? Okay, so I need to go back to my first method, and now I can say push the ball. Now the difference here, of course, is that it says penguin swagger, because that's just the penguin. And then I have world push the ball, because that's the penguin and the ball, more than one object. All right? And the world has access to all my objects, so that makes sense. All right, so now that we have asked Alice to execute push ball, we can play it. Swaggers. Well, that was a bit magical, don't you think? Okay, so the idea is that when you get this immediate feedback, you know right away that you need to debug your code, right? Not only do you know right away that you need to debug it, but you know where the bugs are. Yes? I have done studies, and Steve Cooper will talk about that later today, where I have not told teachers who get Alice students that these students took Alice. I don't want the teachers to know who took Alice and who didn't, because I'm comparing, okay? And I've had teachers run into my office and say, I figured it out. I know who the Alice students are. And I say, why do you say that? Well, because when they have bugs in their programs, they know where the bugs are. Wow. That's pretty cool. All right? I didn't tell them they were right. Okay? But I do now need to go back and modify my code. So what I can do is I can say, I need to ask Alice, how far is the penguin from the ball? That's called asking a question. Unlike a method, which is just the action, I can ask a question using a function. In Java, we call these functional methods or non-void methods. They have a data type, okay? Whereas void methods are the actions. And so in Alice 3, we call these procedural methods and these functional methods. They're both methods, but they do different things. Okay? Now, a functional kind of method allows us to ask a question. So I can ask Penguin, what is your distance to the ball? So I can just drag this in here, replace my 1 meter placeholder with a question that asks, tell me how far the penguin is from the ball. All right? And then I play. Oops. Now what? Want to see that again? Were you watching? Watch again. Would you say he went a little too far? He kind of absolutely collided with the ball? Yes? That's because the distance is measured from the center of the penguin to the center of the ball. Okay? Now, if you're working in civil engineering and you measure from one pier of the bridge to the other pier of the bridge, you know you've got to think about, the center Yes? So these are not silly little things. These are very important problem-solving concepts. All right? Now that you see this in Alice 2, shall we go and take a look at it in Alice 3? Excellent. Let's do that. Let me just save this. Alice gets very upset if you don't save the world. All right? Okay? So I'm now going to go into Alice 3, and trying to save a little time here, I already have it started up. And I've already selected the same snow scene. All right? I now need to do the same thing here in Alice 3 that I did yesterday in Alice 2. I need to set up my scene. I have selected the snowy ground and the blue sky as the sort of the stage. All right? Well, I could have had green grass and blue sky. I could have a moon surface, you know, so the different surfaces. I have, once again, a gallery of different kinds of 3D models. And once again, these are all classes, and they're organized into packages. We're a little more sophisticated in labeling things here. So I have a package, and inside my package I have a second package of animals. And inside there I have a class named Penguin. And I want to instantiate an object of this class, so I select the Penguin class. I say, name the penguin Penny. You have to give it a name. At the top you can see here that Alice says the Penguin class is read-only. I expect that you may want to write your own methods. And therefore, I am going to automatically extend the Penguin class and create the My Penguin class. And the penguin that you are getting is an instance of the My Penguin class. Does this make sense? Yes? Would I do this with 8th graders? No. All right? I'd go back to Alice 2, where I don't have to use that kind of technical vocabulary. All right? So now I have the penguin. And I can go and get from the, well, I can go and find the, I can't, go to the sports. Here we are. I can get a ball. We'll get a soccer ball because we're in Brazil. All right, and go into shapes and get a disc that I can put on top of the snow and make it blue. So I'll have a hole in the ice here. I'll call it water. All right, I have these little rings. Whenever I create an object, it gets a little ring around it. That ring allows me to turn the object, and you can see it's most definitely 3D. I also have some little handles here that allow me to rotate the object in various ways. All right, and if I get the poor penguin too out of position so he's likely to fall over, I can right-click on the name Penny and tell him to orient himself to upright. Okay? I can also ask to see a layout scene view, so I can look at this from sort of above the scene, and I can line up the penguin and the ball and the hole in the ice. Now that hole in the ice is a little difficult to see, yes? Unlike in Alice 2, in Alice 3, if we want something to change, if we want the water to be blue, for example, what I really have to do is I have to write the program code to make it blue. I cannot just make it blue here in the scene editor. And that's because we're going to go into Java, and I can't just have it be magic. I have got to show the students how I did it. Putting too much stuff under the covers is not good. All right? So what I do is I go back over here, and now I need to work with the My Scene class. I need to add some code to make that water be blue and more visible. Right now, I don't know about you, but on my monitor screen here on my laptop, it's hard to see where that water is. All right? So I'm going to go right away into the Perform My Setup method that belongs to the My Scene class. I am writing the method on the class, not the object. In Alice 2, you write the method on the on the object. In Alice 3, you write it on the class. All right? And so in here, what I want to have happen is I want to select the water. I want to change the color property of the water. I want to make the color of the water blue, so I call a setter. All right? Yes? A modifier? Okay? And I also want to move the water up just a wee little bit. And so I call move on the water, and I move it upward just a teeny little bit. Let's say something like 0.05, very, very small amount. The Perform My Setup runs when I click on the Run button. It runs immediately before you see the scene. So it takes no time. It happens in 0 time. It's just like, bang, there it is. So as you can see, the water is now blue. Yes? Okay? Are you all right with that? Now, once again, I can write on the penguin. I can select Penny. But notice that it says that Penny is an instance of the My Penguin class, which extends the Penguin class. When we extend, when one class extends another class, it inherits everything from its parent class. So everything that was defined for the Penguin class, the My Penguin class also has. But I can go up here and select the My Penguin class. I can say I want to create a new procedural method named Swagger. And notice that in the Swagger tab in my editor, it says I'm writing this on the My Penguin class. You see the little icon of the penguin. Yes? It's not on the scene. This is the scene. And this is the scene. This is a method for the My Penguin class. All right? Now, when I pull in my statement to have the penguin roll to the left, 0.125, and then roll to the right, 0.25, and then I can just copy this and have it roll back to the left. Notice it says this. It doesn't say penguin. It says this, right? And that's because I'm writing this for the class, My Penguin. So if I had 5 penguins, they would all know how to swagger. Because this means whichever this My Penguin object you picked, right? So now in my run, we won't make the same mistake. We won't have the same bug as we had before. In the run, I can tell Penny to swagger. And when I click on run, that is exactly what Penny does. All right? Got the idea? All right. Tell you what, I've got a few minutes, so let me show you that if I go over here and edit the scene, and I go back in here and say, I'd like another penguin, I can put another penguin in here. I can call this one will be a young lady penguin, Maria. All right? So here she is. And notice that when I select Maria as the instance of the My Penguin class, Maria knows how to swagger. And Penny knows how to swagger, because I didn't write it just for Penny. I wrote it for the My Penguin class. Right? Excellent. All right. Yes. So I'm going to save this file. Save as. Once again, folks, I'm saving the world. All right? And I'm going to call it Penguin Game. I'm saving it. Penguin Game. All right? Now, you are in my class, my course. We have been working with Alice for about 3 weeks. You have learned about sequence. You have learned about concurrency. You have learned about methods and functions in 3 weeks. It's amazing. And now, we want to lift the hood. We want to look at the Java code. Yeah. So, File, New Project. Give me a Java project from an existing Alice project. In other words, folks, lift the hood of this car. Okay? Click on Next. It says, which Alice project would you like me to open up for you? So I'm going to click on the little Browse button and go get it. Penguin Game. It's a .a3p file. That's an Alice 3 program or Alice 3 project file. All right? Click on Open, and this is where it comes back, and it says, okay, I found it. And now I click on Finish, and I pray. Ooh, This is NetBeans. It is a Java IDE, interactive development environment, right? An IDE for Java. And if I say, okay, I want you to set this as my main project. This is where I want you to find main, okay? And I click on Run. Oh, yes. Isn't that lovely? Yeah. I know I've got the right one. So, are you ready? All right. When I open up the project on the left-hand side here, you can see I have mycamera.java, mycircle.java, mypenguin.java, myscene.java, snowy ground, soccer ball, sunlight. Oh, this is just so good. Yes? Each one of these Java files is a class, right? It defines a 3D model as used in Alice. Yes? We have, if I open up the MyScene class, what you will see is I have instantiated the sunlight object. I have instantiated the snowy ground object. I have instantiated the camera, the penny, soccer ball, water, and Maria. Yes? I have created those objects. And where we wrote code in Perform My Setup, all right, I have this scene's water set color to blue. I have this scene's water move up, all right, move in the direction up 0.05 meters. Code known as Java. And I can look at the run. And in the run, I say for this scene, I want Penny to swagger. Now you are my student. You are sitting in my lab, and I tell you modify it. I want Maria to swagger. Can you do it? Yes? You're going to look at this and you're going to say, well, to get Penny to swagger, I had to have this, which is this scene, yes? Dot what? Maria. What? Just start typing S, W, pretty soon NetBeans figures out, oh, there's only one method that begins with SW, it must be swagger, yes? So I can click on swagger, and notice NetBeans is so cool. It puts the parentheses in, it puts the semicolon at the end, and guess what? If I click on run, we just transitioned from Alice to Java. Was that easy? Just a little bit of sugar helps the medicine go down. Yes? Okay? All right.